Here is the final question, question number 6 from the AP Calculus AB exam in 2025. In question 6, it says consider the curve G defined by this implicit equation, and we need to show that dy dx is equal to this quotient. So the first thing I would do is I would take the derivative of each term implicitly. So the derivative of y cubed is 3y squared dy dx. Minus the derivative of y squared is 2y times dy dx. The derivative of minus y is minus dy dx. And then the derivative of 1/4 x squared would be 1/2 x by using the power rule, and then that would equal 0. In order to show that this is the derivative, I then like to collect all the dy dx terms to one side and all the terms that do not contain a dy dx to the other side. The reason I do that is so that I can factor out a dy dx. And then from there, I would divide both sides by 3y squared minus 2y minus 1. And this is what I got, but then I noticed, wait, it doesn't match up with what's given. And I thought, well, how algebraically can I get to what's given in part A? And I can do that by simply multiplying the numerator and denominator by 2. And this is okay to do because essentially I'm just multiplying by 1. And now I can see that it matches up with what I am given in part A. Now, this derivative I am going to have to use for the next part, which says that there is a point P on the curve G near the point 2, -1 with x-coordinate 1.6. Use the line tangent to the curve at 2, -1 to approximate the y-coordinate of point P. In order to write the equation of a tangent line, I do need to know a point and a slope. The point is given, that's 2, -1. But now I need to use the the slope from part A to find the slope. So I would use the dy dx given to us, and I would evaluate this slope at the point 2, -1. By plugging in 2 for x and -1 for y, I see that my slope, or my dy dx, at the point 2, -1 is -1/4. Now I have enough information to write my equation of my tangent line. That is y minus y1, or y plus 1, because it would be y minus -1, equals the slope, -1/4, times x minus x1, or x minus 2. Then I would simply subtract the 1 over, and now I can plug in the x-coordinate of 1.6 to approximate the y-coordinate at that x-coordinate. So this is what I would have from here. If it were me, I would simply leave my answer like this on an FRQ. You do not have to simplify, and you could get this far and do everything correctly, but then simplify incorrectly and lose the point that you've just worked so hard to gain. So I would end there, but if you're curious to know what that would simplify to, doing some fractions, we can see that it would simplify to an answer of -9/10. But again, I would just leave the answer as this line right here. In part C, it says for x greater than 0 and y greater than 0, there is a point S on the curve G at which the line tangent to the curve at that point is vertical. And we need to find the y-coordinate of point S and show the work that leads to your answer. So you do need to understand on this one that when we have the line tangent to the curve at a point vertical, that means the slope is undefined. Now again, the slope was given to us in the problem, and so in order for that slope, that quotient, to be undefined, that would mean the denominator would have to equal 0. If the denominator was equal to 0, that would give us a slope that is undefined. So now we need to solve this equation. So we're solving for when 3y squared minus 2y minus 1 equals 0. I solve this by factoring that quadratic, and solving, I get y values of -1/3 and +1. Now, I had to go back and read closely. It does say on part C that y is greater than 0, therefore I would not include the answer of -1/3 and only give the y value of 1. And it did say find the y-coordinate of point S, so once we find that y-coordinate, we are finished with part C. And now for our last part D. It says a particle moves along the curve H defined by the equation 2xy plus natural log of y equals 8. And at the instant when the particle is at the point 4,1, dx dt is 3, and we need to find dy dt at that instant and show the work that leads to your answer. This is a related rates question. So we need to take the derivative of 2xy plus natural log of y equals 8 using related rates. So the first thing you would want to do is take the derivative of 2xy, and we would need to use the product rule. So the derivative of 2xy using the product rule and taking the derivative with respect to t would be 2 dx dt times y plus 2x times dy dt. And again, that would be using the product rule. And then the derivative of natural log of y is 1 divided by y times dy dt, because it's related rates and the variable that we're taking the derivative with respect to is t. Everything needs that chain rule. And then the derivative of 8 is just 0. Then I'm going to plug in all the information that I'm given. I know that x is 4, y is 1, dx dt is 3, and I'll use this to solve for dy dt. Doing some simplifying, I get 6 plus 8 dy dt plus 1 dy dt equals 0. Combining those dy dt like terms, I get that 9 dy dt is equal to negative 6. And solving for dy dt and then reducing my fraction, I see that dy dt is negative 2/3. So that's it. That was the last question from the 2025 AP Calculus AB exam. Check out the description below where I've provided links to the other 5 questions from the AP Calculus AB exam. And I hope you found this helpful, and I would love to hear in the comments below. Have a great day, everyone.